but we hadn't quite gotten to the scientific notation. So hopefully the idea of scientific notation is not new to you. You've seen this before. So scientific notation is a method of writing numbers using powers of 10. It's used when we deal with really, really big numbers and really, really tiny numbers. So if we're talking about like the weight of a planet, or if we're talking about the weight of an atom, like we would use scientific notation, okay? It also makes multiplying and dividing with really huge numbers and really small numbers very quick. So we do this a lot in science classes in particular. So I don't really like tell my students to move to the right and move to the left and so on. I really just tell them to know whether or not you have a really big number or if you have a really small number. So really huge numbers are going to have positive exponents. Really small numbers are going to have negative exponents, okay? So we will talk a little bit about the right and the left, but don't like try to memorize that because then people will mess it up when going from scientific to standard and then standard to scientific. They just get them confused, okay? So the first one, it says change to scientific notation. So if we have 1,300,000, is this a big number or a small number? It's a big number, right? So when we are writing this in scientific notation, we're going to first try to get our number. Do you guys remember between 1 and 9.999? So basically there's a 1 number and then a decimal point, not 0 and then a decimal point. Okay, that's the rule. So we're going to move our decimal place over, and we're going to move it 1, 2, 3, 4, 5, 6 places to make that number 1.3. And then the 6 goes on the power. So we do 1.3 times 10 to the 6th like that. You guys all remember that? Yeah. So if I'm changing 250, it's not a tiny little decimal number, it's a big number. So we move our decimal place over 1, 2 places, and that puts it so that it's 2.5, and then we do times 10 to the 2nd because we moved it 2 places. Okay, this next one is a tiny little decimal, so we have to move it. We're going to move it so that we have 5.6, right? We want that number between 1 and 9.999, right? We want one number before the decimal point. So we're going to move it over 1, 2, 3, 4, 5, 6, 7. So it's going to be 5.6, and it's a tiny little decimal number. So we say times 10 to the negative 7, like that. It's a negative exponent. Remember, negative exponents do not mean that the number is negative, right? It just means that it's a tiny little number. It's like reciprocal. All right, so this next one, I have 0.3. So I move it over 1 place, so I get 3. You can write 3.0 if you want. And it's times 10 to the negative 1. Okay, so let's think about what that means. 10 to the negative 1 is 1/10. If we have 3 times 1/10, that's 3/10. Is that the number that we had? Exactly. That's why the negative exponents work the way they do. It's like dividing by 10 or 100 or 1,000. It's moving the decimal place. All right, so the next one. So go ahead and try these along with me. See if you get the right answers. So we moved over 1, 2, 3, 4 places. So I'm going to have 2.5 times 10 to the 4th. The next one I'm going to go 3, 6, 9, 10 places. So I'm going to have 3.89 times 10 to the 10th. Michael, you with me? I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places again. But now this is a tiny little decimal, right? So it's going to be 4.5 times 10 to the negative 10. And then the last one is 6.89 times 10 to the negative 1. We move it over just one little space, right? Okay, is that all familiar to you? You've all done this before. Okay. All right, so just like that, if we have scientific notation, so we're changing from standard to scientific, we can change from scientific to standard. So I guess I didn't do any of those examples. I just went ahead and did the multiplying and dividing. Okay, so scientific notation makes multiplication and division of large and very small numbers much simpler. Okay, and this is the type of problem that you guys have on your homework, so the multiplying and dividing. And it uses the rules of exponents that we've been talking about, okay? So if I have 3 times 10 to the 2nd times 2 times 10 to the 4th, what I do is I really think about the 3 times 2, and then I think about the things with powers, 10 to the 2nd times 10 to the 4th. Well, 3 times 2 I know is 6, and 10 to the 2nd times 10 to the 4th is 10 to what power? 10 to the 6th, exactly. So see how quickly you can multiply and divide. So same idea on this one. If I have 1.4 and 2, 1.4 times 2 is 2.8. And then if I have 10 to the negative 2 times 10 to the 4, let's think about it. 10 to the negative 2 times 10 to the 4. You can move that 10 to the negative 2 on the bottom if you want, or you can just add their exponents, right? If you add the negative 2 and the 4, what do we get? 2. So we get times 10 to the second. If you want to do the thing with negative exponents where you put it in the opposite location, that works as well. 10 to the 4th divided by 10 squared is also 10 to the 2. Okay? All right, so it does get a little bit trickier. So if I have 7.6 times 2, do you guys know what 7.6 times 2 is? 15.2. So we're going to have 15.2 times 10 to the 20th. Okay, these are the ones that you probably didn't do in Algebra 1. Okay, so let's think about it. 15.2 times 10 to the 20th. Is this in scientific notation? It's not. What's wrong with it, Kenzie? Yeah, that 15.2, we need it to be 1.52, right? It's bigger than 9.999 and so on. Okay, so we need to change it. So there's a couple different ways that you guys can do this. Okay, so what you could do is you can change 15.2 and you can say, well, I know 15.2 is 1.52 times 10 to the 1st. And then when I multiply by 10 to the 20th, I have 10 to the 1st times 10 to the 20th. So my final answer is 1.52 times 10 to the 21st. So you can do it that way. But the way that I like to think about it, without writing all that work out, is I say, oh, if I'm multiplying by 10 to the 20th, that means that I'm going to take this decimal point and I'm going to move it. So I'm going to move it over 20 times, right? So I go over 1, 2, 3, 4, 5, 20 times. But then if I brought it back, how many times would I have to bring it back so that it's not right here, but instead right here? 21 times. Do you guys see how we get the 21? So that's kind of a good way of thinking of it too. Say, okay, well, I go out 20 times, but then I have to come back 21 times. So it's going to be 1.52 times 10 to the 21st. All right, and then same idea with division. So I have 9 divided by 3. 9 divided by 3 is 3. And then I have 10 to the 3rd divided by 10 squared. That's going to be 10 to the 1st. So it's 3 times 10 to the 1st. We typically do put a first when we do scientific notation. All right, the next one is going to be 3 times 10 to the what power? 5th. We subtract our exponents, exactly. And then this one's a weird one. So 8 divided by 16 is 1/2. I'm not going to write it as 1/2, though. I want to write it so I can see the decimal. So 0.5 times 10 to the trick question. It is 12, right? Because this 10 to the negative 4 would go up as 10 to the 4th. Or you can do 8 minus a negative 4, and you get 12. All right, so we're going to have, yeah.
How do you get the exponents on 4 and 5?
Oh, I subtracted my exponents. So if I had 10 cubed over 10 squared, it's just like if I had x cubed over x squared, you'd subtract. All right, so if I have 0.5 times 10 to the 12th, let's use that trick I was talking about. If I have 0.5 and I move it over 12 times, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, how many times do I move it back so my number is between 1 and 9.999? Yeah, I move it back right here, right? 1 less, so it's going to be 5 times 10 to the 11th. So if you don't like that method, you can always do what I did before. You can rewrite 0.5 and you can say, oh, 0.5 is 5 times 10 to the negative 1. And then I still have times 10 to the 12th, so I just add those numbers, negative 1 plus 12. Okay, making sense? Maybe? Okay, questions on any of that? All right, so quickly, let's do a couple more review problems of what we did yesterday. Yeah? Don't you wish? So go ahead and flip to, at the end of the chapter, I have some additional notes. We're going to try a couple more examples. So I think the things that were throwing you off are the ones that I had negatives in there and things inside parentheses. And let's just do y to the 5th. Okay, so let's say we have something like that. Okay, so try along with me. Be active note takers. I always say this. So try the problem along with me and see if you get the correct answer. So we're going to write in parentheses negative 2x raised to the 3. and then in parentheses 3y, all raised to the second, and then all over 8xy to the fifth, x to the negative 4. It's a long chapter, isn't it? Chapter 5. Are you finding the end of your notes? It's a long one. Lots of stuff in chapter 5. All right, so when I have negative 2x all raised to the third, I do negative 2x times negative 2x times negative 2x. Okay, so what am I going to get for just that part? How about Nick? What do I get? Negative 2x times negative 2x times negative 2x. Not 16, close. Negative 8. So negative x cubed, 8x cubed. All right, Jacob, how about the next one? 3y squared. 3y times itself.
Oh, 9y squared.
Uh-huh. And then I still have my 8x, y to the fifth, all over x to the negative 4. All right, so my negative 8 out front, that does not move, right? Negative 8 does not have a negative exponent. It stays right where it is. But I do have my x to the negative 4th. So we're going to move positions, and we're going to make it x to the 4th. So I'm going to have my negative 8, my x cubed, my 9y squared, and then all over 8xy to the 5th. And that x to the negative 4th is now x to the positive 4 on top. All right, so I look for things that are going to reduce. So my negative 8 and my 8, those do reduce down. What am I left with? Negative 1, right? All right, and then my x's. So I have x cubed, I have an x to the 4th on top. So I get a total of how many x's on top? 7, and then I have 1 x on the bottom. So I'm going to have 6 left on top, right? So I'm going to have a negative 1, and then I'm going to have an x to the 6th. I still have my 9, and then I have a y squared and a y to the 5th. So what's that give me? Y to the 3rd on the bottom, exactly. So my final answer is going to be negative 1 times 9, so negative 9, x to the 6th all over y to the 3rd. Did we all get that? Okay, do you guys want to try one more? Does it help that I say you have a quiz tomorrow on this? Does that make you want to do one more? Yeah, Zach's looking at me like I just said the worst thing in the world. All right, so let's do this. So let's say I have 8x to the 5th, y to the negative 2, z to the negative 3, all over 2x all raised to the 4th, y to the negative 3, z to the 16th, all raised to the negative 2. About as hard as I get, guys. If you can do this one, you can do any of them. So it's one step at a time. We do not panic. One little thing at a time.
That's the first step.
First step, panic. So let's handle these inside parentheses first. If I have 2x raised to the 4th, so it's 2x times 2x times 2x times 2x. Eric, do you know it? 16x to the 4th, exactly. So I'm going to replace that with my 16x to the 4th. All right, do you want to do the negative exponents right now too? So I have y to the negative 2, I have z to the negative 3, and I have y to the negative 3. So it looks like that x to the 5th stays where it is, and that z to the 16th stays where it is, so I'm going to put that in. But anything that I just circled in blue is going to move. So that y to the negative 2, when I take its reciprocal, it puts it on the bottom as y to the positive 2. So I'm going to have y to the positive 2. I'm going to have my z to the positive 3 on the bottom. And then I'm going to have y to the positive 3 on the top. And it's all raised to the negative 2. Yep, so we're going to try to simplify on the inside. Oops. So when I simplify, Eric's saying let's take care of the 8 and the 16 and reduce that down because we don't want to raise things to the 2 and then reduce, right? We would much rather reduce first. Okay, so I'm going to have a 1 and a 2. And then I'm going to deal with my x's. So I go through and I'm like, okay, I have x to the 5th. I have an x to the 4th on the bottom. Yep, so an x on top. And then I'm going to go through and look for my y's. So I have a y cubed and a y squared. So I get a y on top, right? And then how about my z's? Z to the 19th, exactly. And we're all raised to the negative 2 still. So now what do I do when I have a negative exponent on the outside? Yeah, you can take the reciprocal of everything on the inside. So when I take the reciprocal of everything on the inside, I have 2z to the 19th all over 1xy, and I'm raising it to the 2. You don't really need the 1 there, right? 1xy. So 2 squared is 4. How about z to the 19th raised to the 2nd? Z to the 38th all over x squared, y squared. That is your answer. Does it make more sense today? You feel better about it. All right. All right, let me stop there.